Now, the first thing it's going to say is that this is a parallelogram. So I'd say angle 1 will equal angle 2. All right, you guys? Angle 3 will equal, sorry, I'll just do 3 and 4 here. I know it's a bit random. Angle 4 will equal angle 5. Angle 6 will equal angle 3. Angle 7 will equal angle 8. Angle 9 will equal angle 10. Angle 11 will equal angle 12. Why? Alternate. Any sets I see, yeah? And then I didn't label that one 13, okay? Probably don't need all that anyway. Now, it's a parallelogram, happy days. Proof that xz is equals to yz. Now, the first thing I need to do is need to locate xz and yz. Xz is this one, yz is this one. For me, that means proof that this yellow triangle equals what? That blue triangle. Would everybody agree with that? If I can prove that yellow equals green, or sorry, blue equals yellow, I'm in business. Okay, first thing I'm going to do is, what's the name of the blue triangle I just coloured in? Blue triangle, anybody? What's it called? XZD, triangle XZD, yeah. And what's the other one? BYZ, okay. Now, to get marks, without knowing anything, to get marks, here's what you write down. ASA, SSS, SAS. You know it's not going to be RHS because I don't think there's any right angles, but there could be. Write down that you're set to attempt the question. Yay. Now, let's start off with the obvious. I would say that Z is the midpoint of BD. That to me means that D to Z is the same as what? D to Z is the same thing as B to Z. Why? Z is midpoint of BD. Am I with you? Are you with me so far? Yeah. Okay, you'd want to be. Now, let's see if there's any angles I can obviously state. I'm going to say angle 5 equals angle 4. Any reason why? Alternate. Good job. Okay. So I currently have an S and an A. Now if I could lock in something else, I'd be in business here. Angle 7 equals angle 8. So far, if you look at what I've done this one here. You could also do third angle, couldn't you? Who did third angle? Yeah, you can do it that way as well. Everybody see the two of them are equal to each other? Okay, and what I'm about to say next is that I'm about to say this one equals this one, and then I'm also going to get this one equals that one. See the way I have SAS on both of them? That's the way I'm going to go. There is other ways of doing it though. You could also say that, no, not line color, I want the highlighter color, excuse me. All right, there we go. You can also say those two equal each other. Why? They're also alternate, aren't they? And does it say Z is the midpoint of XY? Doesn't say that. No, it has to be SAS, I believe. Has to be SAS. You can't do SASY. There's no way you can prove any other two sides equal each other. Does it specifically say that Z is the midpoint of XY? No, I can't say XZ equals ZY. That can't be done. Can I say XD equals BY? Does XD equal BY? It does, but can we say it currently? No, not allowed. So we're going to have to work with ASA. Going to go back where I started from. Just here, yeah? And everybody happy with ASA then? So I'm going to go for the other angle. What's it? Angle 8 equals angle 7. And what does that translate into then? Or is it angle 7 equals angle 8? It's angle 7 equals angle 8. Why do I have to say angle 7 equals angle 8? Can anybody tell me? Yeah, angle 7 is in the first triangle and angle 8 is in the second triangle. Okay? Angle 7 equals angle 8. And why are we going to say that? Vertically opposite. Is that okay with you guys? We all good? Okay. Now, therefore, what can we say? Triangle XDZ and BYZ are congruent. XZD and BYZ are congruent. We'll just drag it down here. How do I say therefore? What do I need to write? Three dots, yeah? Dot, dot, dot. Okay, move on. Okay, awesome. PB and BC bisects the angle shown. Proof that PX equals PY equals PZ. Somebody keep track of what questions I'm doing. 10 and 14 so far. Okay. Ouchies. Alright, what is the location of PX, PY, and PZ? Let's find out. Ooh, dear. It's going to be tough. PX, PY, PZ. Those three there, yeah? I have an idea. I have a construction idea. Here's my construction idea. Why don't I draw something from A to P? Like that. What can I say then? Huh? If P is joined to A, prove that it bisects it. I'll give that a second. I won't do that just yet. That's what you have to do for part 2. I am somehow going to try and convince I'm going to try and lock in on. What am I going to try and lock in on? Have to prove they're congruent, don't I? I'm going to try and prove that this triangle here is exactly the same as this triangle here. What will that do for me? It will prove that PY equals P. It will prove the first part. One step at a time, yeah? Alright. What are the names of the orange and yellow triangle respectively? What are they called? PYC and PXC. So triangle PYC and triangle PXC. Now, first thing, we'll need to label some angles, aren't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We good so far? Okay. Now, what's the first thing I'm going to say? Angle 1 equals angle 2, angle 2 equals angle 1. Why? It's given. It's a bisector, isn't it? What else can I say? I can say that angle 3 equals angle 6. Can I say that? Angle 3 equals angle 6, both 90 degrees. I can do the third angle now, can't I? I can say angle 5 equals angle. And why can I say angle 5 equals angle 4? Third angle, isn't it? Do y'all have to add up to 180? Third angle. Okay. I could definitely go for an ASA here. Why do I see that an ASA is on? They share a side, don't they? So what can I say there? PC equals PC. And because PC equals PC, we can have an ASA for that. Now, I haven't all the way there yet. So PC equals PC, common side, isn't it? Now, this is the S, 4 is the A, and 2 and 1 is the other A. So it's therefore ASA, and you can say triangles are congruent, can't you? Therefore, triangle PYC. I have to use 3 equal signs, don't I? For congruent equals PXC. Okay, stop there. Now, lads, what Thomas had was a good idea there. What he also said is to get PX into the mix. What you need to do is you need to concentrate on the square at the bottom here. Now, the reason why we're going to know it's a square is that we can say that angle 9 plus angle 12 is what? Angle 9 plus angle 12 is 90. So angle 9 equals angle 12, which equals 90 degrees. Okay. This means that BX has to be perpendicular to ZB. Yeah, it means they're all perpendicular to each other. So it follows that angle 3 plus angle 7 is 90. And it also follows that angle 11 plus angle 10 is also 90 degrees. This means said PBX is a square, not necessarily a square, is a rectangle. Would you agree? Yeah, it's a rectangle. Can't say it's a square. Looks like a square. Can you say it is a square? What am I trying to prove? PZ equals? I can say it's a rectangle. Now I have to prove something else. Give me a second. Now I'm going to rub out my first answer and concentrate on the second answer now. What I'm going to have to prove here, if I split this in half, what can I say? I can say that, yeah, I'm going to have to prove that the top triangle is congruent to the bottom triangle. I'm going to prove that the red triangle is congruent to the green triangle. Does that make sense? I'm going to prove the congruence. Yes, Danny? It doesn't say anything about them being parallel, but they actually are automatically parallel if it's a rectangle. So you're right, we can do that. So 7 equals 11. Sorry, 7 equals 11 and 3 equals 10. Yeah, I'll get there. Don't worry about that. I'll get there. Yeah, you're right, Danny. You are correct. Okay, I know. Now, guys, let's do this really quickly. Okay, angle 3 equals angle 7. What's that? Given. Okay, and angle 7 equals angle 11. Reason being, alternate. And what Danny said is it is a square. Danny's correct. Then what we say is this implies that angle 3 equals angle 11, which implies an isosceles triangle, doesn't it? What does it imply an isosceles triangle? That 11 equals 3. And because it's isosceles, what does that mean? That means said P must equal said B. And in turn that must equal PX and BX, because it has to be a square. Good job, whoever did that. Okay, Danny. Now, we've proven what we wanted to prove, didn't we? That PX equals PY must equal PZ or ZP. Done. Question 1, done and dusted. We good? What about part 2? P is joined to A. Prove that. I'm going to get rid of that angle 15 for a second because I'm going to have to break it up into angle 15 and angle 16. Fun times. That's a handy one, lads. It's a handy one. Handy dandy. Right. We got this. It's an easy one. We want to prove that angle 15 equals angle 16. This one's 15, that one is 16. Everybody cool with that? Now what can we do next? Start it off. We want to prove that 15 equals 16. Yes, sir. Angle 13 equals angle 12. Why? Yeah. 90 degrees, yeah. Straight angle has to add to. Okay, what's angle? We can also say the same for angle 14, can't we? Angle 14 has to equal angle 3. Therefore, angle 13 equals angle 14. So we've initially showed that that one equals that one. Everybody cool with that? Okay. We've also shown that, it's an RHS, lads, for the first time. An RHS. How do I know it's a RHS? We already proved that PZ equals PY. So that's our R. Why is that R? Because they're both right angles. Now we're going to have a side. We're going to say that PZ equals what? PY. And we say proven in part 1, yeah? And then finally, what's the hypotenuse of both triangles? and that is S. Where's the angle? Right angle. That's hypotenuse, isn't it? And that's S. Therefore, RHS. What are the two triangles that are saying are congruent to each other? APZ is congruent to APY. Everybody cool with that? Any questions? Okay, let's go for this one. In the triangle PQR, PQ equals PR. So if you want the last question, that diagram is a bit small for us, so I'm going to make a much larger version of it. Do something else. Current page. Bit more accessible now, yeah. Now, angle 1, angle 2, angle 3, angle 4, 5, 6, 7, 8, 9, 10. Everybody cool with that? Okay. So, prove that Sx equals Sy. Essentially, it wants me to prove that. What does it want me to prove? Which two triangles does it want me to show that are congruent to each other? SQX, and which is the other one? So, to prove XQX, triangle SQX is congruent to SRY or SYR. Is that all right? Now, let's begin. Okay. Does it tell anything are the same lengths? All right. These are the same length as each other, aren't they? P to Q is the same length as P to R, which means what? Angle 5 must equal angle 10Y. Isosceles. Not to say it isn't equilateral, but it's definitely isosceles. Okay. I can then say angle 4 equals angle 9Y. About 90, aren't they? And what can I say then? Angle 6 equals angle 7. Or angle 6 equals angle 8. Y. Third angle. I need one side, don't I? I just need one side to make this work. Why does QS equal SR? Given. Alright, that was easy peasy. Why didn't anybody get that? Did you just get scared by the diagram, really? Alright, so everybody knows that's a midpoint, isn't it? S is midpoint of QR. Lads, the explanations I'm giving, see the explanations in the writing? They're just as important as the bits to the left. You won't get full marks without explanations, okay? So, I've proven Sx equals Sy then, haven't I? Have to now prove Px equals Py. Where's Px? There. Where's Py? There. Okay, have a plan. Okay, what's my plan? I'll think about this before I record. Now, lads, here's what we're going to do. We're going to draw a line from P to Q. Or sorry, P to S, okay? Now, we're going to focus. Ready, guys? Look at this. Shh, really quickly. I want to prove that the triangle PXS is congruent to the triangle PYS. Good job, by the way. Now, I'm first going to say angle 2 equals angle 3. They're both 90 degrees, aren't they? So that puts in me for the R. PS is a common side for both of them. So what does that do? Huh? Hypotenuse. Okay, common side, so it's the hypotenuse. And then finally, SX has to equal SY because we proved it in part 1, didn't we? We proved that those two triangles are congruent. So that's SX equals SY. That's one of the other sides. Therefore, we have an RHS. Well done. Better than the one I was coming up with anyway. Everybody cool with that? Therefore, PXS is congruent to PYS. All right, XQ equals YR, the last part. XQ equals YR. Where's that? Where's xq? We already proved that. If they're congruent with each other, in part one we proved that those two triangles are congruent with each other, didn't we? So if these two triangles are congruent, and we know that angle 6 and angle 8 are the same, that means that xq and yr are the same length. We're done. Good job.